Hey everyone, thanks for joining us this morning. Aboriginal spirituality recognizes the connectedness of people and culture with sky, earth, and water. The land is alive with traces of dreaming ancestors. Adelaide Sustainable Building Network acknowledges the Kaurna People of the Adelaide Plains as the traditional custodians of the land we live on, and Tarntanya, where our work is most often undertaken. We pay our respects to elders past and present of all Aboriginal nations. And as professionals in the built environment, I hope we can all use our work practices to look after country in the same way country looks after us.
Thanks, Christina. With that, we will have a nice sip on our tea and welcome Katie Eyles to join us to the wonderful SustainabiliTEA today. So Katie is a sector lead in embodied carbon at NABERS. She's joining us to share the ins and outs of the new NABERS Embodied Carbon Tool, which I'm very excited about, launched late last year. The tool provides a certified measure of carbon intensity, incorporating material, transport, and construction emissions. And I personally think it's a very exciting and welcome introduction to the industry, because obviously we're all looking for a standardized way of measuring and reporting embodied carbon. So Katie's going to give us a short presentation and we'll throw over to you. Thank you, Katie.
Great, thank you. I might just start with a little bit of a very quick introduction to NABERS, because I think probably most of you know NABERS pretty well if you're in the building industry, but yeah, just in case. So yeah, at NABERS we measure environmental performance of buildings on a 6-star scale, just to make it really easy to understand how you compare with the rest of the market, anywhere from making a start to a 6-star being market leading. And the point of that star rating scale is that we're doing a fair comparison. We have an algorithm behind that takes into account things that affect whatever you're measuring. So if you're measuring energy use in a building, we would take into account things like area, building type, what is the use of that building, so that we can put everyone fairly on that scale, kind of comparing apples to apples. So yeah, we certify buildings on a few things. Embodied carbon is, of course, what we are talking about today. And I guess to give you an idea of how widely spread NABERS is, these are just a few snippets from our website of active ratings. Operational energy ratings are mandated for buildings over 1,000 square metres when they're sold or leased, so we tend to have a lot of active ratings around Australia. And probably, the main thing that we like to talk about with NABERS is, I'm sure all know this, measurement leads to improvement. So for example, with office operational energy ratings, we've found that over 10 years, buildings are using close to 40% less energy, and shopping centres moved even faster. So hopefully with embodied carbon, we can do the same sort of thing. In terms of the embodied carbon tool itself, we started working on that a few years ago in 2021. The first thing we did was spend a couple of years talking with, pretty much everyone who's involved in creating buildings. So everyone from developers to architects and engineers, policymakers, and building product manufacturers. What we were doing when we were talking with everyone was understanding, well, if we're going to create an embodied carbon measurement method, what do we need to take into account? So for example, how much of the building are we measuring? Are we trying to measure everything down to the nuts and bolts, or are we focused on the materials that make a bigger impact, like your concrete and your steel, the structural elements? We're talking about things like, are we trying to measure whole of life, right through to when the building is eventually demolished, or are we measuring upfront carbon just until, people are starting to use the building? What emission factors should we be using for materials? All these kinds of things we discussed with everyone to kind of like agree together as an industry what the right way to go was. So yeah, that's why it's been kind of a long road to get to this point. But the tool is out now, and essentially what the embodied carbon tool is these 5 things. So a set of rules which standardizes what you're measuring and what documentation you need as evidence that you've measured it appropriately. A emission factors database, So if you have if you're using materials that have measured emissions, such as in an environmental product declaration or a carbon footprint, that's best, use that. But if not, you use the default emission factors in our emission factors database that we've published. Thirdly, training to ensure that people who are using the tool to measure embodied carbon are all doing that in a consistent way and following the rules consistently. Certification, which is, NABERS essentially auditing what we've been given, the information that we've been given by someone that wants a rating, confirming that everything's correct, that the right evidence is there. And then finally, the benchmark, that 6-star rating scale, so that you can easily, see how you compare with the rest of the market. So yeah, that's essentially an overview of what the tool is. And I'll go into a few details about each of those things now. If we're talking about measuring embodied carbon, what are we actually measuring in terms of the building's life cycle? We're focused on upfront embodied carbon. So yeah, everything from raw material supply to when the construction process is complete. The reason we focused on upfront embodied carbon, there's a few reasons. It is the biggest part of the picture in terms of emissions. So a paper that ASBN recently published showed that around 65 to 75% of all embodied carbon in a building are that upfront picture. And, we need urgent action right now, of course, to reduce emissions as quickly as we can. Once the building is built, we know what's gone into it. We can easily measure that. And yeah, we get questions, of course, about whole of life carbon because, it's important to balance what you're doing now with the rest of the life of the building, how often you need to replace things or how energy efficient it's going to, all those kinds of things that you guys would know to focus on in your day-to-day work. But if we were to try and measure whole of life carbon, we'd be making a bunch of assumptions about the future, which pretty likely to be incorrect. So, we want to make decisions today that are informed by whole of life considerations, but we don't want to rate the whole of life picture because we don't want to, trade off higher emissions now for things that may or may not happen in the future. So yeah, really focused on upfront embodied carbon to, make that urgent action happen in reducing emissions. But we do provide a whole of life calculator as well that you can play around with to help you understand the whole of life picture. It's just we don't certify that. We only certify upfront. In terms of measuring upfront carbon, it's kind of simple in a way, just the quantity of each material times the emissions of that material, and then adding on transport emissions, construction energy, and then emissions from the waste that occurs during construction. Let's take a look at what each of those things mean. So if we're talking about measuring the materials in the building, what is the scope of that? We're focused on the main structure of the building. So yeah, substructure, superstructure, envelope, some of the bigger internal items like floors tend to make a reasonable impact of at least, 1% or 2% in the overall picture. But we're not going down to measuring details such as fixtures and fittings and fit out materials. There's a couple of reasons for that. It would be quite hard or time intensive to measure absolutely everything in the building, and also to get good quality data for everything in the building. Once we have measured the main structure, we're already measuring about 90% of the emissions associated with a building. So more practical to focus on the bigger ticket items. And also focusing on the main structure helps us make it a fair rating because when a new building is built, whoever's doing the fit out might be different from who's building the base building. So yeah, it's easier to make sure we're consistent and that everyone's measuring the same thing and that it's a fair system as well. So to give you an idea what that looks like, we have in the rules a list of all of the materials that need to be measured. So you can see it's pretty consistent across building types. There's a couple of crosses here for internal walls for retail and industrial. The reason why we don't include those for retail and industrial is because they can quite often be considered part of the tenant fit out. So that that information might not be available when you're doing the building in the first place. So yeah, and they're also a smaller percentage of overall emissions for those building types. So yeah, really just the goal is to make it consistent for everyone so that everyone can measure the same thing and we're measuring what's in control of the developer. So then, yeah, once you know what materials you need to measure, what evidence do we require of what was actually put into the building? This part is really important. We need as-built evidence, so things like delivery dockets or returnable schedules or receipts or other evidence of what was actually delivered to site. This is really important because we know that at the moment that information is often not being collected as the building is being built. So yeah, that is quite a big deal at the moment, how we can get processes to change so that people are collecting that evidence during the construction process. Really hard to get it later once construction has been completed. And the reason why we require as-built evidence, not for every material, but for the major materials, the reason we require that is because we know that, what's planned isn't necessarily what's actually delivered. So we don't want to be, rating things incorrectly, basically. So then for your materials, what emission factors are you applying to the materials in the building? There's a few different options or a few different methods of measuring emissions, different LCA life cycle methodologies. So there's process-based, which is looking at your specific product and everything from, getting the raw materials to when that material is finished being manufactured. What are the emissions associated with that specific process? Process-based measurement is great in the sense that, you can differentiate between, my timber product and your timber product. And there are also international standards that guide the scope of measurement so that everyone's, measuring the same things, makes it comparable. Then we have like kind of the opposite end of the scale, input-output measurement, which is a top-down approach that uses economic data to estimate emissions per economic sector. So input-output method is not useful for, looking at the emissions associated with a building specifically because you can't differentiate between products. Then we have hybrid, which combines, kind of seeks to get the best of both worlds between process-based and input-output. So it's kind of mainly similar to the process-based method, looking at your specific material, but also includes some things that aren't included in the process-based method. So, for example, it might take into account the development of the machinery that you use to create a product, or other things that aren't included in the process-based method. And hybrid, probably some of you are pretty familiar with using hybrid data because you might have been using the EPIC database, which a lot of people have been using over the last few years. The concern with hybrid is that there isn't an international standard for exactly what scope you're measuring, which means that hybrid data isn't really comparable. So therefore, we heard a strong preference from industry for using the process-based method and not databases like the EPIC database. So if we're looking at process-based emission factors, here's what we're talking about. Environmental product declarations, EPDs, carbon footprints, which are compliant with the same standards or you're measuring the same scope as what you are in an EPD, or climate active product certification. And if your product doesn't have one of those measurements, then you can use the NABERS default emission factors, which have been created using process-based data. So we developed the emission factors database because, of course, not all products have a measured emission factor at the moment, and there wasn't any other source in Australia for Australian products of product-specific emission factors that were up to date and that covered everything we needed to cover. So we realized, oh, okay, we need to create one. So I'll talk a little bit about how we developed that emission factors database. The first thing we did was collect all of the EPDs and other process-based emissions data that we could find for products available in Australia. So that includes both products manufactured here and those that we know are imported, because we're trying to cover everything that's used in Australia. Then we worked with industry or mostly the product manufacturers, to define, okay, if we need default emission factors for products, what are appropriate categories to have an emission factor for? So you can see on the screen here as an example for what we wound up with for steel. And really what we were looking at is what is an appropriate grouping of things that are manufactured in a similar way so that the emissions are reasonably similar, and things that are used for a similar purpose in a building. So that was the level that we needed to go down to for the different levels of steel. So for example, in structural, galvanized sections needs its own emission factor. So we had all of the emission factors data. We had what types of materials needed their own default emission factor, and then we held industry workshops with manufacturers, LCA professionals, quantity surveyors, anyone else who knows about emission factors and was interested, to make sure that we had all the data to figure out what is an appropriate methodology for creating default emission factors, and also to like cross-check against other sources. So for example, if we use the methodology we've come up with to come up with a, or if we look at the data that we've collected, how does that compare with other sources such as AusLCI? Oh yeah, and importantly, checking if the data was too skewed to like one specific area in Australia or one manufacturer. So once we kind of went through that whole process, we came up with a method for developing the defaults. This is just a snippet from the database, and I'll just talk through what it means. So for each of the product types that we need a default emission factor for, we have the maximum in category, that's the maximum emission factor that we found in any EPD. We have the minimum, that's the minimum that we found in any EPD, and then the average, pretty self-explanatory. Then we have a data qualitative rating. So we have tiers 1, 2, 3, and 4. There's just 4 tiers. But essentially what this means is how much information were we able to find for that product. So for example, if there's a bunch of EPDs out there and a lot of companies are reporting data, we have good market coverage in terms of companies or manufacturers and also locations around the country. That's a tier 1. Our data's pretty good quality. Once we get down to tier 4, that means that we don't have too much information. Maybe we were only able to find 1 or 2 EPDs. Yeah, that's a more problematic area. We use those tiers to make an uncertainty adjustment. So you can see for tier 1, we're just adding 2% uncertainty, whereas by the time we get to tier 4, because our data is not good, we're adding 20%. So what we have, the methodology that we are using is we take the maximum emission factor that we found in any EPD, and then we add on that uncertainty factor. So for 10 MPa to 20 MPa, we're just adding on 2% to that maximum that we found. So the default emission factors that you'll be using in a rating are these ones in the blue row, and you only use those if you don't have a measured emission factor for the product. So the reason why they are conservative is because, first of all, if you don't have measured emissions for a product that you've used, we don't know what the emissions are. So we don't want to underestimate and rate a building as better than it is. We want to steer people towards getting measured emissions. We don't want the default emission factors to be, better than what you might get in an EPD. And yeah, I mean, mostly the issue is that if you don't have measured emissions, we just don't know. We know that products that do have EPDs tend to be better performing than ones that don't, because those products, they're actually measuring and improving. So yeah, they are conservative in that way. But yeah, feel free to ask questions about this later. We do get a lot of questions about the methodology. That database and the rating calculator are updated each year to make sure they're up to date. But yeah, definitely better to find products that have measured emissions, such as with an EPD, because you will, of course, get a much better result because you're using known measurements. So that's kind of A1 to A3 sorted, the emissions associated with your products. Now let's talk about A4 and A5 quickly. So yeah, transport, waste, and construction energy. Emissions for those, we have methods of modeling in the rating calculator. So if you don't have any information about those things, then you just use the defaults that are modeled by us. And if you're curious about how they're modeled, the calculator has a lot of different tabs in it that kind of explain where all of the data is coming from and how we've calculated it. So yeah, if you're curious about that sort of stuff, feel free to download all the explanations from our website. But if you do have information about transport waste and construction energy, you can replace our default assumptions with your own data if you have it. That's pretty much the tool in terms of what we're measuring. I think it's important just to note we have a lot of national agreement on the tool. So it was developed in partnership with the GBCA and industry. It's aligned with international standards for measuring embodied carbon in buildings. And we've been working closely with infrastructure and transport as well to make sure that we're doing things in consistent ways. And yeah, it's in policy in a few places, so this wouldn't apply to you guys, but for New South Wales, our Sustainable Building SEP uses this measurement methodology for embodied carbon. There's the Federal Environmentally Sustainable Procurement Policy, and it is also written into the next update to the National Construction Code whenever that comes out as a voluntary pathway. If you want to take a look or want to start using the calculator to estimate your emissions for buildings, that's all free and available to download from the NABERS website. So yeah, there's the calculator. If you go to our estimate your rating page, you can find the embodied carbon calculator there. Or if you're looking for the rules about what to measure or the emission factors database, they're all available on our embodied carbon page. We want people to use it. We want people to estimate. Totally free to estimate. The only time you would have to pay to use it is if you're actually submitting a rating to us for certification. That's about it. So yeah, I'll throw back to you guys for any questions.
Thanks, Katie.
Love it. Absolutely. First things first, I guess curious as to the iterative process of where you've got your different banded tiers of different, embodied carbon of concrete, for example. I know there's been some work that has been coordinating between the Materials Embodied Carbon Leadership Alliance, and they've, I guess, come up with some banded efficiency bands, if you like, for different types of carbon intensity for different concrete mixes. And I'll get to my question in a second. But what are the current, I guess, rules around claiming, perhaps savings associated with different tiers or bands? Do you compare it with your default concrete mix, or is there work in progress to maybe look at an efficiency band that might be industry standard, or what are the?
So yeah, I guess really for us, what we're focused on is what data is published in EPDs, because we know that has been quality checked and that it has been measured in a consistent way. And yeah, we do speak a lot with the MECLA folks about, what they're working on and how they're measuring things. One thing that we've been speaking with them about a bit lately is the different applications for concrete and whether we potentially need to base the default emission factors on what the application is, because I guess something like if you're creating a really smooth floor in a warehouse, the emissions for that sort of a mix that's used for that is typically higher than something that's not so high stakes. But yeah, for that one, for example, we're really just waiting for more information because, for example, the concrete application isn't necessarily noted in an EPD, so we don't have a way of knowing what the applications are for the concrete mixes we have data for. So yeah, I would say it's evolving constantly in terms of how much information we have and what we need to do with that information, and that's why we will be updating the emission factors database every year. But essentially, ideally, you have used a product that has a measured emission factor and you just use that.
But yeah, I guess also moving on from that, with your average emission factor, for example, and you use a product with an EPD, your delta, your difference between the two, is that typically classified as the saving from an average emission factor?
So for NABERS, we don't look at like a base case versus an improved case. So yeah, we don't look at savings at all. We just look at what the actual calculation is.
Yeah, sorry, yeah. Absolutely.
Yeah,
No.
but yeah, that is, yeah, of course, that's relevant for Green Star, and they are moving to use our emission factors, but they haven't put the details out yet of what their results are from the consultation they just did on that.
Yeah, I would actually just on that love to hear a bit more about kind of the scoring process and the benchmarking process. Have you already got set benchmarks associated with each of the rating scores, or is that still happening as people do these ratings?
Yeah, we do have benchmarks. So the way we benchmark is we collect data for a lot of buildings and then essentially do statistical analysis to see if you have, for example, a 20-story office building in Adelaide CBD, what would we expect the emissions to be for that building? And then so, for example, for embodied carbon, we collected data for 140 buildings, and that was across different building types, the offices, residential, including things like hotels, apartments, student accommodation, all that sort of stuff. Schools, residential aged care, retirement living. Yeah, pretty much like all of the major building types where we know a lot of buildings are being built over the next few years. We did a life cycle analysis for those 140 buildings and then use that to create the rating scale. So if you're doing a rating, for example, for a like a 20-story office building in Adelaide, and your final measurement is, for example, 700 kilograms of CO2 emissions per CO2 equivalent per meter squared, and we know from our data set that typically an average building is 800, then you would get a star rating that is higher than 3. Or if your result was worse than typical, then you'd get a star rating lower than 3.
So with the buildings that were the data that you used to develop the benchmarks, were they a range of different performance, or were they all quite efficient and now the benchmarks have been set on efficient buildings? Or
yeah, they were a range. So we just collected all of the data that we could get from a few different quantity surveyor companies and also some property like development companies. And we use a mean of 3.25 to set the scale, which means that a little more than half of the buildings are above 3-star and then the rest are below 3-star. And we have a pretty even spread from like 0 to around 4. And the reason why we don't have ones which are higher than 4 is because we need to have some room for improvement in the scale. So, for example, when we created the operational energy rating benchmark, that was created about 25 years ago. And we've gotten to the point now where the average that building score is around 4.5. So there's still, room to move over the years. Rather than like if we were changing the scale as we got more buildings, then it's a bit hard to know what to aim for or what limits to set in policy or that kind of thing because it's constantly moving.
Thanks for the presentation. Will developers and builders use this tool to inform their choice of materials? And if so, are the emission factors suitable to compare embodied emissions across material types?
Yeah, definitely hope so. Yeah, so I guess if you do an estimate by putting in all of the materials that you intend to use and then swap a few things around, like say, okay, well, what if we do use a different structural method for the building, then yeah, you'd essentially just be comparing what is the emissions story with this method versus what is an emissions story with that one. We don't try to steer anyone towards using a particular construction method or particular materials. All we care about is what is the total amount of emissions, and how you get there in terms of what materials you use, totally up to you.
I guess what I'm just trying to understand is for the emissions factors that you have, are we comparing apples with apples? And I appreciate you did talk about the scope at the beginning of your presentation, but I know with LCAs, you can have slight differences in methodologies and boundaries. So for the emissions factors that you extracted and have put them in there, are they all comparing apples with apples so that you can have a direct comparison between material A and material B in terms of their embodied emissions?
Yeah, they all use the same method of measurement, so that product-specific process-based method. Yeah, so there's clear rules around how to measure that.
Yep, so with the same boundaries and everything like that.
Yeah, exactly. Yeah.
Brilliant. Thank you very much.
Yeah.
So when Clive started in industry, embodied energy was only about 10% of whole of life energy. However, because operational energy has been reduced, embodied energy is higher as a percentage. Do you know the current percentage as an average?
Well, Green Star did some research a little while ago, which showed it was about 50-50. But yeah, I'm not 100% sure, sorry.
I could probably jump in there. We did a comparison for a 30-story office building in Melbourne, comparing whether or not it was built in 2020 to 2030. And there was actually quite a significant difference. I couldn't quote you the exact numbers, but 50-50 sounds about right for the sort of the 2020 numbers. But obviously with the decarbonisation of the grid, if we're meeting targets, you know, you go 60-40, 70-30, and it does grow quite considerably. And so the expectation is that that's probably the direction that most grids are moving. And obviously it depends where you build as well, because, you know, in Tassie versus in Darwin, there's going to be a different kettle of fish.
Great to have more insights on how the tool works. Are you able to share what the average cost would be to use the certification?
Yeah, so there's two elements to it, just while I look this up. So the first thing is what you would be paying whoever the consultant is, the person who's acting as your assessor. And that, yeah, I mean, I guess it depends what other work they're doing for you, or if they're just doing the embodied carbon rating itself. But that would really depend, yeah, on how many days work they would think it would take to do the rating. When we were putting the data together for our benchmarking process, it was taking a quantity surveyor around 3 days to put together the data, or up to 5 days if it was a really huge complex building. So I guess at a minimum, there'd be the cost of that person for a week or two. Yeah, depending on what kind of engagement you have with them and what else they're doing. And then the rating fee that we charge is, you know what, I will look that up on our website while we go to a new question.
I did have one more actually. I know you mentioned about there being kind of a set scope of things you need to include in the model. I've definitely seen in the past when comparing the performance of a few different buildings and things that sometimes the result isn't just dependent on how efficient the design is, but also how detailed and well the LCA that was done on it and key components weren't missed. So how is that going to be essentially monitored to ensure things aren't missed, especially when sometimes there is missing information? The contractor just doesn't have information on how much insulation ended up being in the walls in the end or things like that. Are there any set assumptions or defaults that have to be applied to make sure those key components are definitely all included?
Yeah, that's also actually a really nice segue to the end of that fees question that NABERS charges. So yeah, in the rating calculator, we have, once you've entered all of your materials and quantities, we have calculations which are similar to what quantity surveyors use to make sure that they've costed everything in a building. And that highlights, you know, like it'll highlight any areas where we think we're missing information. So for example, you know, when we're doing the benchmarking, I picked up things like someone had left out the concrete for a basement, or maybe, you know, like the facade to floor area ratio isn't appropriate, or that kind of stuff. So yeah, there's that level of checking. And then we also we audit the ratings when they come in. So someone from NABERS does a careful review of it compared with the floor plans and the original bills of quantity and that kind of stuff, just to make sure everything makes sense. So that is why the fee that we charge for certifying is just under $5,000. So there's, yeah, the reason for that is there's a couple of days of our time checking through it to make sure that everything's included.
Awesome. So sorry, just with that kind of sanity check that happens with the areas and things, is that something that the person who's filling in the materials can see, or is that just a back end thing NABERS can see?
The person filling it in can see, and then we also double check
Awesome.
it.
Thank you. Any other questions?
This is probably a little bit of a selfish one. However, you highlighted sort of like the as-built documentation. That's kind of necessary. And will that kind of generally be following, you know, as-built kind of documentation that's generally been expected for Green Star, so to speak? Just because when you mentioned sort of like delivery dockets and things of that nature, some of the ways, because of the difficulty of kind of getting that at times, projects, I mean, across the nation have kind of pivoted to making sure that contractor sign-offs on quantities, which is basically a validated form that they've actually identified this is the amount of quantities of things, mainly because of just like what a lot of subcontractors have identified is, the exact like price. So in terms of quantity declaration, they'd do material sign-offs on a monthly kind of basis or bi-monthly, quarterly basis. So projects can keep track on that on documentation side of things. Would that also be an applicable way of validating as-built information?
Yeah, I would think so. I'm not sure on the exact details of the Green Star rules, but if a supplier has given you a list of what was delivered and when over the last month, yeah, that would be fine. We just need to know what specific product was delivered. It needs to have like an address, to prove it went there, and the quantity. Yeah. We did find when we piloted with about 30 buildings, and the ones that had gone through Green Star did find it much easier to give us the evidence. So I think there's a reasonable amount of crossover, but yeah, I think maybe Green Star is a little more lenient in some areas, but I'm not 100% sure. But we're also like really aware that it is hard to collect this stuff, especially in the meantime where it's not built into construction process yet. So we're also, like if you have questions or if you're not sure, reach out to us, because we don't want to make it so hard to get a rating that no one can do it, because yeah, of course that would be insane.
Kat's got a follow-up question as well. I understand you've applied an uncertainty level based on data quality for embodied emissions in building materials and products. Taking the conservative approach, this means a higher embodied emissions for those materials that have lower data quality. What's the plan for improving their data quality? i.e., is NABERS going to commission studies to fill them?
We have been working with industry groups, essentially just trying to get people creating EPDs, measuring their emissions. We've been working with other parts of government who can help fund that sort of thing. We can't fund it ourselves, but yeah, essentially we're doing anything that we can with other parts of government and with industry associations to try and get emissions measured so that we do have better data.
I also have another question, which probably loops back with the first one that you answered quite well. So obviously the decoupling of I guess all of the different sort of standardized emission factors and everything from the statistical analysis of LCAs, et cetera, that have been done in industry. Has there been any work done to compare I guess those statistical kind of models that have determined your 3 or 4 star banding versus a typical quantity of materials for an office building with all of your default emission factors to determine what star rating that would get?
Yeah, so I guess the important thing is that the star ratings are based on the star rating scale is based on bills of quantity that we collected. So like actual buildings that were built and what quantities were in them. We have done a bit of work comparing, like for the pilot buildings that we rated, for example, we've done some work looking at the LCAs for them, where they had them, to see where the differences are. Is quite difficult to compare if they have used a different scope of emission factors. So for example, if they were using the EPIC database, or if they have measured a different amount of materials in the building. I guess, often for LCA, they might be trying to measure absolutely everything. So maybe 10% more emissions than what we would be measuring looking at the base building. So yeah, comparison is a bit difficult depending on the scope of emissions and materials. But yeah, we have been looking to compare, on individual cases to see what the story is. Yeah.
That's good to know. It's just curious. Thank you.
Yeah, I mean, I guess that's the whole problem of why we created the tool, because there's a lot of differences in how people are measuring.
So I know a five module of construction emissions is included. Is that currently only capturing emissions associated with a material? Does it capture other construction activities? For example, if the building has a basement, will the excavation of that basement be captured somehow? Because obviously that would be a large portion of emissions compared to an above ground only structure.
Yeah, the defaults that we use are really an average based on like the published data that we could find on construction emissions. So if you are I don't honestly know how conservative it is in terms of different things that would be required during construction. But if you have your own data, it's great if you can collect it and use that instead, obviously.
Having done it bottom up from a plant schedule, it is about 3 or 4 times the amount estimated versus actual. And so it's going to be very interesting to see how A5 falls out.
Yeah. But I guess, that, like everything else, as we get more information, we'll update it.
It's great that it's going to be updated every a year. So I guess I have one final question for the novices in the room. In regards to the training, is that just something that is downloaded, or is it like in person? Do you have to sign up, and is there a cost associated?
Yeah, so we did one training session a couple of months ago to train the first round of people who are interested in being assessors. We had about like 100 people or so in that, and we've got 40 people that have passed their exam already. So the way it works is typically for NABERS, like when we first launch a tool, we do a online training where you have to be present for those couple of days, and then you take an exam. And then after that, we put a course online and you can take it on demand. The reason why we do it in person at first is because if it's a new tool, there's a bunch of questions that we get which help inform like how do we update the training before we put it online as an on-demand course. And it does cost somewhere between high $2,000 and $3,000.
Great. Well, if there are no other burning questions, we might call it a day. And thank you so much, Katie, for sharing that information with us.
Yeah, thanks, Katie. It's very informative. I'm very excited to go around and play around with the tool now.
Yeah. Well, yeah. And if you have any questions at all, just email us at any time. You can just use the NABERS at environment web address that's on our website, and we'll get back to you within a couple of days.